Real estate investment practice problem using Excel. Lender credit method number 2. Get ready because we're raising the stakes with real estate. Here we are in our Excel worksheet. If you have access to the Excel worksheet, would like to follow along, note that we have 3 tabs down below: example, practice, and blank. Let's take a look at them now, starting with the example tab, in essence being an answer key, focusing in on the lender credit, remembering that it is in essence the opposite of points, which we've seen in prior presentations, points being money down up front in order to lower the interest rate, in order to get generally a lower payment amount and possibly a benefit over the life of the loan. The lender credit going the other way, meaning we're going to get cash up front, a credit up front to go towards the closing costs. In order to get the cash flow, we're going to be paying for it in the form of basically an increase in the rate, which will result in it being, increase in the rate over time. Now, in the prior presentation, we looked at this with one method of calculating. Now we'll just do a similar calculation, but with a second method. So we're going to be comparing and contrasting a situation where we do not have the lender credit and one in which we do have the lender credit, remembering that under either circumstance, we still have the closing costs that are going to be there. It's just a matter of how are they going to be covered. Are they going to be covered by an upfront cost upfront from us, or are they going to be covered by the increase, the spread, in essence, of the rate, increase in the rate, which means we're basically paying over the life of the loan, including the closing costs in that way. So in the first instance, we could think of it as we saw last time, of just saying we got a $250,000 loan and then we paid the closing costs, versus a $250,000 loan in which the closing costs are basically credited to us. So we got kind of that benefit of the credit up front, which is going to result in an increase in the rate. Or we can say, okay, both ways we're going to have these closing costs that are affected, and we could then calculate the effective rate here using the closing costs, in essence, rolling in the closing costs to the actual effective rate. So if our actual rate was 3% and the closing costs were $9,000, we're just making up the $9,000 here, and then we can roll that into the effective rate, which is similar to how the kind of APR is calculated, to say that we'd have an effective rate of the 3.289. So we'd be calculating the loan balance here based on the 3%, but we could say the effective rate for comparative purposes, rolling in the closing costs, would be the 3.289. That's one way to try to close everything out into one rate for comparison purposes. If we look and compare it to the rate over here where the closing costs are going to be included or paid for by the lender in an exchange for an increase in the rate, then we got the 3%, and then we're going to say the rate's going to go up by the 0.75. So now the rate is going to be the 3.75 on the 250,000, and then they're going to give us that credit, which we can take towards the closing costs. So if I was to take my effective rate, in essence, we still have the closing cost of the 9,000, but then they kind of were nulled out. They were paid, in essence, by the lender up front. So if we take that into consideration, those two components, we can calculate the effective rate, which basically gets us back to the rate after we take into account the credits. Okay, so hopefully this makes a little bit more sense once we get to the actual calculations. If we go to the blank tab here, this will have a tab with cells that are pre-formatted in blue, so you can work along with less formatting. And then in the blank tab, we will just make everything from scratch for the areas where we will be calculating. So we're going to start off here with our item that does not have the closing costs and the lender credit paying for the closing costs, but we would like to roll it into the effective rate. So let's calculate this. We're going to say the effective rate is going to be, we want that right underneath the rate up top here, because that's what we've been doing in the past. Then we've got the lender credit percent increase. We're not going to have any at this point. We've got the closing costs. We're going to add the closing costs here, and we're going to say that the closing costs are going to be 9,000. Now the closing costs could vary. You can estimate it as basically a percent of the loan amount, but we're just going to assume 9,000 at this point. And then we got the lender credit. Now if we took the lender credit, it would have to be equal to or lower than the closing cost typically. We're going to start off with no lender credit, and we'll add the points here just so you can use this worksheet for points if you needed the points too. And then we've got the rate decrease per point, which would be 0.0025, which was our worksheet that we were working on. That could change, but we'll keep that here. And then make that a percent. And then we got the points fee, which would be equal to the loan amount times 0.01 times the number of points here. So if we had points of, say, 1 point, we'd have 2,500. We're not going to have any points on our example. And then the rate after points or percent credit. So this would be the original rate that we had up top. If we had points, it would be minus the points, which would be the 0.25 per point times the number of points that we have. And then we're going to add to it plus the lender increase if we had an increase in the rate, which we're not going to calculate on this one yet. So that's going to be there. And we're going to make that a percent number group, percent, add a few decimals. So we're still at the 3%. That's going to be our starting point. Our amortization schedule is being calculated based on the 250 loan, not including anything with the closing costs because those are going to be paid up front. And if we scroll all the way down, then we've got the 0 down at the bottom, so it looks like it's calculating properly. Now then we can calculate the effective rate, taking into consideration the closing costs, even though they're not part of the loan, to try to roll it into one percentage. So that if I was to compare against another loan that had different closing costs, then I can compare the same thing to the same thing, right? So we can try to get this one rate. This is going to be equal to the rate, brackets. We're going to take the number of periods, which is going to be 360, comma. You need a negative on the payment. The payment's going to be the 1,054.01 calculated down below, comma. The present value is usually the loan amount. And that's what we got. We received the loan, in essence. We can imagine getting the money and then paying it to the lender, so to the seller. And then we also had the closing costs that are going out, right? So the closing costs are decreasing. So we're going to say we received 250 minus we had to pay 9,000 for the closing costs up front. So from a cash flow standpoint, we got 250 minus the 9. And if we make that a percent number group, percentifying it, adding a couple decimal, we're looking at an effective rate of 0.274. That's for a month. Let's multiply it times 12 times 12, and that would give us the 3.289. So effective rate 3.289 if we roll in the closing costs higher than the starting point rate. Now let's copy this over and think about the rate if we were to say that we got a lender credit to in essence pay off that $9,000 and increase then the rate for the lender credit. I'm going to copy all the columns going from A on over to I, right click Control C, going to paste that in column K now, and we're just going to say I got to adjust anything that's an absolute reference in my formula. So I'm going to double click on the payment and say that then equals this payment down below, F4 on the keyboard, $sign before the L and the 17. Double click so we can copy that down. Interest rate also has something in there, so I'm going to double click on that. We want to make sure that we pick up the rate, which is going to be down here, the 3% after we take into any consideration any changes. Make that F4 on the keyboard, $sign before the L and 15, and then double click on it, copying it down. Then I'll typically make a change up top. What if I was to make this 2%? Would my amortization table calculate properly, meaning 0 at the bottom here? Does look like it does, so that looks like it's doing what we would think it would do. Let's put it back to 3%, and then we could say, okay, let's add our new piece of data, which is going to be that we're going to say that we're going to get a lender credit in exchange for the 0.0075, adding some decimals, number group, percent, few decimals, 0.75% increase in the rate. So we got that calculated down here automatically. So we go from 3%, the rate that's going to be calculated on the $250,000 loan. We're going to be increasing it by 0.75, which is going to be something determined by the lender in exchange for the credit of the 9,000. Again, that relationship will kind of change. It'll vary, so you have to see what you can get in terms of this change. But we're going to assume that we're offered 0.75 increase, which would bring the rate that's going to be used to calculate on the loan balance, $250,000 to 3.75, and then they're going to pay off, in essence, using a lender credit, the $9,000 of the closing costs. So we're going to assume that the lender credit is going to be equal to the closing costs of the $9,000. So now if I look at the effective rate, in essence, what has happened, if I look at the effective rate, I double click on that, we go back to this, the payment, the present value, in essence, normally we got the $250, and then we've got the closing costs, which we usually pay up front, but we didn't pay them. We got a credit for them. So I'm going to add back the closing costs up front. So in essence, basically we're paying we got $250, which we're paying to the seller, and then we normally would be paying the closing costs, but we basically got a credit from the lender, so that kind of nulls out the closing costs, right? We can imagine they gave us $9,000 for closing, and we gave it back to them in the first period. So basically our cash flow goes back to simply the $250,000 in terms of a cash flow basis. That means that our effective rate is the same as our rate after we consider the change for the lender credit percent at the 3.75. So now we have basically a $250,000 loan, and we got a credit up top that paid for the closing costs here, versus over here where we got the $250,000 loan at basically the 3%. You can see the difference in the effective rate. The effective rate when we take on the credit is higher, which is what you would expect, because the bank is going to want to make their money. They want to make it worth their while. They're going to make the money back over the life of the loan. But then, of course, we're gonna have to say, well, how is this going to play out? Because we have this timing difference as to when this is going to be beneficial. Because in essence, we got like that $9,000 up front. Now, in this scenario, notice that these two rates are the same. The effective rate is basically the same as the rate down here. So this one should be basically the same, rate for the life of the loan. This one, we have a different kind of effective rate up top than the rate down here. So we're going to actually focus on this side and try to find out, at what point in time it's going to be the break-even point where the effective rate here, or the internal rate of return, will be equivalent to the 3.75. So we could do our same kind of thing, and we could try to figure out, okay, well, what's the break-even point based on this calculation? Same calculation for the break-even point that we saw in the last one. So we'll say break-even. Let's make this a little bit wider. Let's put a point there, break-even point. That's how it's supposed to say. Let's make this black and white. We'll go to the bucket, black and white on the bucket. And so we're going to call this then the lender credit. The lender credit is once again equal to the 9,000. That's going to be the difference between the two. And we have a difference in payments. So if we just look at the cash flow difference to pay this off, we got the payments with credit. So if I was to have the credit, I'm going to have a higher payment of about 1158, taking the pennies off. Payment spelled wrong. Payment. And then payment without. And this is going to be equal to the payment without the credit over here. Payment without the credit, 1054 about. Let's underline that by going to the font group and underline. And so we have the difference in the payments, which is going to be equal to the 1158 minus the 1054. And so we got a $104 difference about. And so then we're going to say the break-even point in months is going to be equal to that 9,000 divided by the 104, or 87 about. And then the break-even point in years is going to be about equal to the 87 divided by 12 months, about 7. Let's add some decimals, a couple decimals, about 7.23. And for some reason I put a negative number here. Let's make that a positive. Get rid of that negative. Let's put an underline here, underline. Let's make that our blue. Do the blue thing. drop down, border it, bluify it. Let's do some indentations, a little bit more fancy here. We'll do some indentations. Going to indent here and indent there. So that looks pretty good. Widen the cell just a bit, just a tad. Okay, so that's about the break-even point. So 87, if I go down to 87, I got 100, this green and 100. I'm going to ungreenify that. That's not the spot. That's not the right spot. We were looking for 87, which is right there. So 87, that's the approximate spot where we think these two things will cross over, breaking even. Okay, so then we can kind of test that with our IRR calculations. We could say, okay, let's do an IRR and see if that is indeed the case. So we'll say, let's do one over here. And we'll say, let's start one out with no credit, to kind of prove the rate itself. So we'll do the whole thing. This is going to be the cash flow. Cash flow, no credit. We're going to then make this black and white. Make it black and white. Let's put the wrap text. Let's go ahead and center it. Centered. We'll put our payments of 1, 2, and so on. Let's make this a little smaller. This is 0, 0, 1, 2. Bring that on down to the 360. Taking it on down to the 360 periods. There we have it. Let's center it. And then we're going to have our cash flow. So the cash flow, when we had no credit, we're going to say is equal to the loan amount, which we received, minus the closing costs that we're putting up top. So we got the money, and then we paid $9,000 up front. So the net cash flow is actually $241 that we're assuming here. Then we made payments. We made payments just calculated on the $250,000 of the loan, not including the closing costs. So that's $1,054. If I copy that on down, all the way down, and go on down and say, okay, what that adds up to total payments down here, the total, summing this up equals the SUM, summing up the total payments. We get to the 138,444, or the net, the net flow. And this is going to be the IRR then. The IRR is going to be equal to the IRR. And let's pick this whole thing up. And we got to multiply it times 12. So pick that up times 12. So this is what the formula looks like. Let's make that then a percent. Add some decimals. We get to the 3.289. So if I go back on over 3.289 and 3.289, that's going to be our effective rate. So we kind of proved our effective rate. Let's do the same thing with a credit here. So if I say with credit that was involved, so I'm going to copy from X to Z, copy from X to Z, paste that up top, and I'm going to say this one, we're going to say with credit. With credit. The value starting point this time, we're going to say this time we've got 250, and then we had to pay. You can imagine kind of paying the closing costs, but then we got a credit for the closing costs, so that kind of nulls itself out. So we're actually back to, in essence, just the loan amount of the 250. And then if I say minus the payments, which are now the 1158, and then copy that down, copy that on down, and we have our same totals in the IRR. This is going to equal the sum of these items. And then the IRR is going to be equal to the IRR of these items. Taking this whole column here, and we'll multiply that, close it up, times 12. So if I look at that, there's the formula. We're going to make it a percent, add some decimals. So that's at the 3.75, which of course matches the effective rate there. And that effective rate is the same, of course, because these two cancel each other out in essence as the actual rate that we're using to calculate the amortization table. That means that the second one, that rate should be basically constant throughout this whole set of periods. So if I'm trying to look for the break even, I'm trying to look for this one. I'm trying to find this one, the one that doesn't have the credit, and look for the IRR, which is going to be equivalent to the 3.75 here. So let's try to do that. And so we calculated our break even. Let's try to copy this from A to AC. And this is going to be, once again, with no credit. So we've got our data, which is going to be equal to that 241. This is going to be equal to the outflows with the no credits. And I'm going to go down to 87 payments and look at the IRR there. Let's go down to 87 payments right there. Delete everything below that. So let's remove everything under there. Right click, delete, shift cells up. And let's do our calculation right here with the total equals the sum. Actually, before I do that, we need to say that last payment, we got to pay off the loan balance. So it's going to be negative. I'm going to the first amortization table, which is going to be the 208,364 that we're going to have to pay off the loan balance at the end, plus the 1054. There it is. And then we sum this thing up. Say SUM of this entire thing. Then we'll calculate the IRR, which is equal to the IRR of this entire thing. We're going to add some decimals, number, percent, decimals. I'm going to multiply it times 12 to get the yearly amount times 12. We get the 3.611. Now we're looking for the 3.75. So it's not exactly 3.75. So then we can hunt around, where would it be at the 3.75? Let's try. And I think it's around 68. So if I was to copy that, let's do this. Let's copy these items again. And I'm going to paste this over here. We've got our cash flow, which is going to be equal to this one. It should be equal to this one right there. This should be a negative of that number. Oh, not a negative, of just equal that number. And then we'll copy that down, double clicking, copying that down. And we want to bring this down to around 68. So I just hunted around for it myself, and then we're going to say, let's try it at 68 and see if we get closer to the IRR we're looking for. This is the IRR we're looking for. And we're going to shift the cells up. So let's do our total here. Hold on a second. Before we do the total, we gotta take that ending balance, which is going to be negative of that last amount that we would be paying off, which would be on the first amortization table, that 218,277 loan balance minus that last payment 1054. So there we have it. Then we can total it. Let's total equals the SUM. Shift 9. We're going to take this whole thing. And then we'll do our IRR calculation equals the IRR. And IRR this whole thing. And then multiply it times 12. So the formula looks like that. And then we'll make a percent, add a couple decimals. So now we're at around that 3.75. So that looks like around 68 in terms of the internal rate of return. Looks like it matches up. Basically, our effective rate matches up here. So those are the two ways that you can kind of see it. We looked at the last method versus this method, so you can get an idea of how you can kind of do some comparisons with these different factors and components that would be involved. So the idea, of course, here being that 9,000 is something that you're getting up front. So you're getting basically the benefit up front instead of the cash going out up front. So you would think then that if you basically sold the property earlier, then you might be at a more beneficial. The longer you hold the loan, the more likely the bank is going to be more beneficial to work this out. But again, the whole point of it was to make sure you had the cash flow to finish the deal up front. So the question would be, is it worthwhile to do that in order to close things up? To get things done, typically in the normal scenario.